So here we're going to look at an Excel example of the multiple comparisons procedure, the Tukey Kramer procedure. Okay, here is the formula for the critical range. So let's first find the critical range. So here alpha is 5%. Okay, n the total sample size. Okay, we have that way back up at the top right here. So right below that is C, so we can copy that down here for C. Now to find Q sub A, the degrees of freedom is C for the numerator and n minus C for the denominator. So with alpha of 5% and these two degrees of freedoms, we can find Q sub A or Q sub alpha from the table in the back of the textbook E6. So let's go to the table. Okay, so this is studentized range Q. So we have two tables, one for alpha of 0.05 and then there is one for alpha of 1%. Okay, the numerator degrees of freedom is across the top, so 4 is our numerator degrees of freedom, and the denominator degrees of freedom is right here 16, and you see that 4.05 is the Q sub alpha value for us. So 4.05, that's alpha. Now MSE or MSW, MSE is mean square error, or MSW is the same thing, mean square within sample, and that is from the ANOVA table. Okay, we prepared the ANOVA table at the top, so let's get it from there, which is this mean square W. Okay. Now what are the different hypotheses that we're going to test? So here we have 4 population means and we have to consider all the pairs. So mu sub 1 with mu sub 2, mu sub 1 to 3, mu sub 1 to 4. So that's 3. Okay. And then so we have completed all the pairs with mu sub 1. Next we start with 2, 2 and 3, 2 and 4. And then we have 3 and 4 as the final one. Now the sample sizes are all the same. Otherwise we have to carefully build the sample sizes. So here 1, so sample size n sub 1, okay, and n sub 2 there, C35 and D35, then C35 and E35, then C35 and F35. Okay. Now I'm illustrating individually because I want to cover the situation when the sample sizes are different. So that's why I'm building it individually, even though they are all the same in this particular case. Okay, and D35 is the sample size for 2. So you have D35 and E35, and then D35 and F35, and then you have E35 and F35. Now the critical range, okay, we have the formula for critical range right here. So that will be Q sub A. Okay, you should get Q sub alpha always from here, so that should be made absolute reference, times square root of MSW. Okay, let's put another bracket. MSW must always come from there, so press F4, and then divide by 2. So that's that part. Okay, and then we have 1 over the first n plus 1 over the second n. So we need one more right parenthesis. Okay, then press enter. So that gives you the critical ratio, and you copy that. It's going to be the same, because what would make the critical range different is when the n's are different. If n's are the same, you'll get the same critical range. Now the absolute value of the sample means, the difference in sample means, you have to go absolute value. The sample means are at the top here. The first one is C6 minus D6. Okay, so that's the first one. So that is C36 and D36. And the next one is ABS of C36 and E36. So it's very much like how we built the sample sizes. And then ABS of C36 minus F36. Then ABS of D36, the second sample, D and E, and then D36 minus F36. So that will be the second sample and the fourth sample, third sample and the fourth sample. Then absolute value of E36 minus F36. So that's 3 and 4. Now we can set up a formula for conclusion. So you can say if the absolute difference is greater than the critical range, if it exceeds that, then within quotation mark you type reject HO. Okay, close quotation mark. Okay, otherwise open quotation mark, you say do not reject HO, close quotation mark, close. Okay, that's formatted to right adjust. Now you copy. Okay, so now you see that except for the pair 1 and 4, all other pairs are different. So this is the only one that is not significantly different. So the average sales for in aisle and expert placement, that's your 1 in aisle, 4 is expert placement locations, are not different. All other pairwise mean comparisons are different. The probability of making type 1 error in these cases, when you take all of these different hypotheses together, is no greater than 5%. So that's what the Tukey Kramer procedure validates for us. The probability of type 1 error will not be more than 5%.